Assalamu alaikum to all of you guys. In this lecture, we're going to be looking at the quotient rules of exponents, right? I uploaded a video on the product rules of exponents. If you haven't checked that video out, first go. I'm just going to put its link in the description box below. You could find it and watch it first, then come to this video. It will be a piece of cake then if you just watched out that video first, right? So when it comes to the quotient rules of exponents, you should think of three important laws that you should be aware of if you want to work with, right? The first one is going to be something like, its general form is a to the nth divided by a to the m, right? If you're having the same bases, right, in case of division, but the exponents are not the same, so what you shouldn't have to do is to keep the same base, which is a, subtract the exponents, which is n minus m, right? Keeping in mind this as the first quotient rules for exponents will help you a lot. So let me share with you the very first example from the given textbook, right? That is 10 raised to the power 500 divided by 10 raised to the power 498, right? So applying this rule, keeping the same base, which is 10, subtracting 500 minus 498, we get 10 to the 2, right? So 10 squared, or 10 to the 2 power equals 10 into 10 equals 100. So I hope it's clear, the very first law of quotient, right? So let me just erase it and we'll show you another example from the textbook. That is a to the sixth, a to the negative 4. Applying this law, okay, this rule, which is a 6 minus 4. A minus into minus becomes plus. A to the 10th. Okay? If you want to take its note, just pause the video, then start and pause the video again and again. So 2 to the negative 45 divided by 2 to the negative 50, right? So keeping the same base, which is 2 negative 45 minus 50, right? So this equals 2 to the negative 45, minus into minus becomes plus 50. 2 to the 5th plus 50 and negative 45 becomes 5, okay, positive 5. So 2 to the 5 becomes 32. So the 5th power becomes 32, just removing it. Now, let me just move into the next quotient rules for exponents. That becomes, if we're having something like a to the m, b to the m, what do you think? In this case, the exponents are the same, okay? So what you shouldn't have to do to divide the bases by each other and take the common exponent, which is m. Okay, the very first example is 2 over 5 whole to the 10th, right? 2 over 5, 2 to the 10th divided by 5 to the 10th. The exponents are the same, okay? M equals m, 10 equals 10. But the bases are not, so dividing 2 by 5, and here it's a fraction, okay? We can't divide it. Don't worry, don't divide it, because you're having a decimal representation of a number. You don't need to do so. So taking the common base, the common exponent, which is 10, this becomes the answer. Look at the next example. 2 to the 100 divided 20 to the 100 divided by 10 to the 100. So it becomes 20 over 10 whole to the 100. equals 20 over 10. 0 cancels out with a 0. 2 divided by 1, 2 to the power 100. Okay, that becomes the final answer of the given problem. Let me just share with you the very last example of the second quotient rules for exponent as well. That is negative 30 all to the power 6, negative 15 all to the power 6. So dividing the bases by each other, negative 30 divided by negative 15 whole to the 6th, taking the common exponent. So negative divided by negative becomes positive. 30 divided by 15, 1 and 2. 1, 15, 15, 2, 15, 30. So 2 to the 6th. 2 to the 6th means 2 into 2 into 2 into 2 into 2 into 2. 6 times 6 factors of 2 becoming 64. This becomes the answer to the given problem. Yeah. Now let's move into the third quotient rules for exponents. That is, we're having both of the exponents and the bases the different. What we shouldn't have to do, like a to the m and b to the m. So simplifying each exponent, a into a into a, n times, okay? Whatever the n is, divided by b into b into b, m times. Then what you get, divide them by each other, you will get the answer. For example, 7 squared divided by 6 to the third power, okay. So 7 squared means 7 into 7 divided by 6 into 6 into 6. So 7 into 7 becomes 49 divided by 6 into 6, 36. 36 into 6 becomes 216. Yeah. That's become our final answer to the given problem applying the third quotient rules of exponents. Let me just move into the next example. 5 to the third power, 3 to the fourth power. Okay, so this means 5 into 5 into 5. Here both the exponents and the bases are different. Okay, simplify each of them. 3 into 3 into 3 into 3, 4 factors of 3. 5 into 5 becomes 25, 25 into 5 becomes 125, divided by 3 into 3 becomes 9, 9 into 3, 27, 27 into 3 becomes 81. Look, if it could be simplified anymore, no, that becomes the final answer to the given problem. Let me just show you the final example and we'll just close up the lecture. That is 10 to the 4th, 3 to the 5th. 10 to the 4th means 10 into 10 into 10 into 10, divided by 3 into 3 into 3 into 3 into 3. Yeah, 5 factors of 3. This becomes 10 to the 4th becomes 10,000. And 3 to the 5th power becomes 243. This becomes the final answer to the given problem. I hope this lecture is helpful, guys, and you have learned a lot from this video. What this was about the quotient rules for exponents. So I highly recommend to subscribe to my channel if you are new to my channel, and also share the video's links with other friends if they want to improve their basics of math skills. And yeah, this is the best place, MathBest, to improve your basics of math skills. And I will see you in my next coming video with a new lecture. Fantastic lecture will help you dramatically improve your math skills. So take care of yourself, and I will see you there. Bye-bye.